In this lesson, you'll learn how to perform calculations in C# using standard arithmetic operators. I've already created a new project of Type Windows Forms app, so let's place a button on the form and write some code. Get in the habit of naming form controls as you go along. I'm going to start by declaring and initializing a couple of variables. I'm hard coding their values for now, but later we'll capture them from text boxes on the form. By the way, I can declare both of these variables with one line of code like this. I've saved myself a little bit of typing. I'm also going to declare a variable to store the result of my calculations. I've given it the name result, but any legal variable name will do. Adding together num1 and num2 couldn't be simpler. Result equals num1 plus num2. Add the contents of the two variables together and assign the result of that calculation to my variable, which I've called result. And I'll use messagebox.show to output this to the screen. You'll remember from the previous video that messagebox.show expects to be passed a string, but of course result is not a string, it's a numeric value, so I'm using the toString method to convert it into a string. And we'll press start to test it. That looks fine, exactly what I was expecting. You might also remember from the previous lesson that I don't need to use toString if I do this. This is called implicit type conversion or implicit casting. I'm implying that I want to convert it into a string because of what I'm doing with it, concatenating it onto a literal string. If I simply want to display the result on its own, then I have to explicitly cast it using toString or something similar. By the way, notice that the plus symbol does two different things. It can be used to add numbers together, and it can be used to concatenate strings together. I'm going to stick with explicit casting for now. If I want to multiply one number by another, then I can use the multiplication operator, like this. The multiplication operator in C# is an asterisk. 17 multiplied by 3 is 51. To subtract one number from another, I'll do this. I'm just using the minus symbol. 17 minus 3 is 14. Now let's try dividing num1 by num2. The division operator is a forward slash. It's a bit like writing a fraction. I'm getting a result of 5. 3 goes into 17 5 times. It's ignoring the remainder. I was actually expecting something like 5.6 recurring. It is simply ignoring everything after the decimal point. It has truncated the result. If I want to see a real number result, then one thing I could try is this. I'm declaring result as a real number data type. I'm using double, but I could use float or single or decimal. But that hasn't solved the problem. If I want to perform real number division, then the numbers which I'm dividing have to also be real numbers. So I'm making num1 and num2 doubles as well. And that's the result I was expecting in the first place. As you can see, if you want to perform real number division, then you have to make sure that you are working with real number data types, because the default is integer division. Now there's a reason for this. Lots of standard programming algorithms make very good use of integer division. the binary search, for example. You'll find out more about these standard algorithms later. Another approach I could have taken is this. num1 and num2 have been declared as integers, but I'm going to cast them as doubles before I divide one by the other. And that's working as well. Now let's collect some data from the form using text boxes. Now I can't do that because the text box control always captures a string. I need to cast this value before I can put it into the integer variable. And let's make sure that still works. That looks fine. Another very useful operator is the modulus operator. Before I show you, let's just simplify what's here a little bit. I'm happy to work with integers from now on. The percent symbol is my modulus operator. Let's see what it does. 17 modulus 3 is 2. C# is performing an integer division, and then it's telling me the remainder. So 3 goes into 17 5 times, with 2 remaining. 3 goes into 15 5 times, with 0 remaining. 5 goes into 27 5 times, with 2 remaining. 5 goes into 29 5 times, with 4 remaining. The modulus operator is incredibly useful when it comes to things like cryptography. You will no doubt meet it again. C# also provides a variety of ways to simply increment or decrement the contents of a variable. Let's simplify this code again. The variable result has an initial value of 15. If I want to add 1 to that, I could do this. Take whatever's in result, add 1 to it, and put the result of that calculation back into the variable result. 16, as expected. But I can also do the same thing like this. Result plus plus. 16 again. It's just a shorthand way of achieving exactly the same effect. I can also do it like this. Result plus equals 1. This method is more flexible. Result plus equals 20 means take the value of result, add 20 to it, and store the result of that calculation back into the variable result. Plus equal, then, is not just for incrementing a variable. I can add anything I like to it. And this technique works with other arithmetic operators. For example, multiply the contents of result by 5. Divide the contents of result by 2. Of course, we're performing integer division because that's the default. The final thing I want to show you is how I can raise one number to the power of another. C# doesn't come with an exponentiation operator. If I want to raise 2 to the power of 3, I need to do this. 2 to the power of 3 is 8. If I simply wanted to raise 2 to the power of 2, in other words, square 2, it would have been quicker just to say num1 times num1. It would have also been more efficient behind the scenes. But when I'm working with much bigger exponents, then I need to use Math.Pow. Pow means raised to the power of. The math class and its methods are incredibly useful, and you'll no doubt come across some more of them in the future. Why not try some of these calculations yourself? Collect the data from text boxes on the form. You can also try incrementing and even decrementing a value. What do you think that line of code does? Here's an exercise that you might like to try for yourself. I've got a simple form with 3 labels, 3 text boxes and a button. The idea is I'm buying something from an online shop. The item which I'm buying is priced at, let's say, £10.50. And perhaps I want 10 of them. I'm also going to have to pay for the postage. £3.75, for example. This application uses arithmetic operators to calculate the total amount to pay. In this case, £108.75. If you want to give it a go, pause the video now and I'll show you one possible solution in a moment. I'm going to code up the solution to this from scratch because I want to point out a very nice feature built into this version of Visual Studio, something called IntelliCode. I'm going to need 4 variables, so let's declare them. Now I'm going to initialize 3 of those with the contents of the text boxes. As soon as I start typing convert, then a list of items beginning with CO has appeared. This is called IntelliSense, and it's been around in Visual Studio for a long time. To select convert from the list, all I need to do is press the Tab key. I've typed another couple of letters because I want to convert something to a double, and 2 double has appeared in the list. I'll select it with the Tab key. It's the price, which I want to convert to a double, and as soon as I highlight it in the list, Visual Studio has assumed it's the text property of that text box which I want to convert. I'm happy with what I'm seeing there, so I'll just use the Tab key to select what I'm being offered. Now I want to initialize the postage variable. And look at that. The IntelliCode feature is now predicting the entire line of code for me, and it's exactly what I want. Tab key to select. Let's get the quantity as well. Now IntelliCode hasn't got that quite right. This time I want to cast the contents of that text box to an integer. So I simply ignore what I was offered. Let's calculate the total by multiplying the price by the quantity. Now IntelliCode is making some more predictions, but perhaps those predictions are not that intelligent. But you can see, as I type, the predictions are being refined. Finally, I want to add the postage to the total. And I'll output the total in a message box. By the way, instead of calculating the total in 2 stages like I've done here, I could have done it with 1 line of code, like this. That is called a complex arithmetic expression, because it contains more than 1 operator. Notice how I've used brackets to make it clear that I want the price multiplied by the quantity before I add the postage. The truth is, I don't actually need the brackets in this case, because the multiplication operator has a higher precedence than the addition operator. Without the brackets, I'd get the same result. However, for some complex arithmetic expressions, it may well be necessary to use brackets to get exactly the result you're looking for. You need to apply a little bit of high school mathematics to know where to put them. Sometimes I like to use brackets even when they're not absolutely required. It can make the code easier to understand. In the next lesson, you'll learn about a decision-making construct, namely the if statement. In the meantime, do practice using IntelliCode. This feature, based on artificial intelligence, will really speed up your coding once you get the hang of it. And it will no doubt get better and better in the future.